In this lecture, we'll introduce Cinemachine screen shake when a giant rock comes tumbling down our bridge. We have half a dozen or so just basic obstacles coming down our bridge, but I think it'd be actually really cool if we had one unique obstacle to really add some oomph to our game. In the GDTV assets folder, in the prefabs folder, we have a couple different rock assets that we could actually use. Well, we can go ahead and rig those up shortly, but to make them actually a little bit different than the other obstacles, we can number one, shake the screen when our rock hits different objects in our scene, and number two, we can kind of have a custom cool mesh particle effect to kind of just make it look like the rock is shattering when it hits our bridge. Let's start with the Cinemachine screen shake, and that might be actually easier than you'd think. On our Cinemachine camera in our hierarchy, you can actually just come to the Cinemachine camera component and add an extension. When you click this, you have a bunch of different extensions that you can add. In our case, we actually want to add the Cinemachine Impulse Listener. That will add a new component at the very bottom of our Cinemachine camera game object. We can now add Cinemachine Impulse sources to different game objects in our game and then just actually fire this off through code manually. Now, we don't actually have our rock prefab set up yet, so as an example, let's actually just set one up directly to this Cinemachine camera. Let's go ahead and add Cinemachine Impulse Source. You can actually test this out to see what it would look like when you're in play mode using this invoke button. You can actually see that it's grayed out when we're not in play mode. But if you are in play mode, for example, you can actually just click this invoke button. It will actually just shake this screen according to these settings. Well, for the rock actually shaking and hitting the bridge, I think something pretty basic like this probably makes a lot of sense. So you can actually click this little tiny triangle here. If you were to say change it to something like explosion, for example, you're actually going to get a different curved shape. So when you hit the invoke button, it'll just kind of look a little bit different. So we don't actually want this on the Cinemachine camera itself. Let's just go ahead and remove this component entirely. We can go ahead and add that to a rock prefab. So let's actually go set that up as a prefab variant of our base obstacle. So just like all the others, let's just take some time to create that rock prefab. Let's right click, create a prefab variant forking off of this base obstacle, and we'll just call it rock. Let's go ahead and open that up. We can go ahead and navigate into our GDTV assets folder. In the prefabs folder, you could probably use either rock. I'm actually going to use this mossy one. I think it looks quite nice. Or if you really wanted to go the extra mile, you could even perhaps randomize between the two. But for our sake, we'll just use just this one for now. I'm going to drag the mossy rock underneath my model, and we just want to blow this bad boy way up, probably somewhere to around there relative to the size of our cube. So let's go ahead and actually just kind of center that where you'd think it would be, and just delete the cube entirely. We don't actually want to use this mesh collider. We can go ahead and delete that here. On the rock, the most parent game object, let's go add a capsule collider. And we can just kind of roughly get this in shape where we'd imagine it to be. I'm also noticing the box collider is still attached as it was on the base obstacles. So let's make sure we delete the box collider component entirely. I think I just want the capsule collider on this one. I don't want this on the y-axis. I could probably have this on the z or the x-axis, and that would be just fine. Let's shrink down my radius a bit, shift over my height just a little bit more, and then just shift things around roughly on the z to have that just roughly in place of where we think it would be. Probably just a little bit too low. I'm just going to shift that up ever so slightly. Don't think we need to be too precise about it. Probably something around there looks good. Maybe just a slightly wider radius, and then I think I'm set to go. I think I'll probably have a little bit of overlap here on the bottom, but I think it will be just fine from the player's perspective. Before we navigate away, let's assign a new material to our physics material settings. So let's go create a new physics material. In our physics material folder, I'll just actually start by duplicating this one here and renaming it to rock. My goal here in between the rigid body settings and the physics material settings is to really just get it feeling really heavy throughout our game. So I'm going to have a really high dynamic friction. I'm going to have a pretty high static friction as well. And unintuitively, I think I actually want a pretty high bounciness. So I'm going to have something like 0.85 just to make sure it's really slingshotting through our bridge. I think that'll make a little bit more sense a little bit later on once we introduce the custom particle effect. Friction average is fine. Bounce combined. Let's just actually change that to maximum to see what that looks like. Let's navigate back over to our rock and modify some of these rigid body settings. I think I want the mass significantly higher than everything else, just to kind of make it look like the rock is pushing everything else around. So let's try a mass of 50. Let's have some pretty high drag on the rock to make sure that it's not actually moving too fast throughout our game while it's bouncing around. And then a pretty high angular drag compared to everything else, just to kind of make sure that it's not actually flipping around too fast. After this rock prefab has been created, we just want to make sure that it actually has a chance to spawn in through our obstacle spawner. So with our obstacle spawner clicked, let's hit the plus button and then just drag the rock prefab in. And you know what? For testing purposes, let's actually just go ahead and delete all of the other obstacle prefabs just so we have nothing but rocks spawning in. I think that'll make testing a little bit easier as we go along. Doesn't look like I can actually hit the delete key, just highlight all of them and then press the little minus button. So now with just the rock inside, let's actually see what that looks like. Blow up our game view. I also just kind of want to see that the relative size of the rock is about where I want it. Okay, number one, I think we could actually make the rock bigger, and I don't think I assigned my physics material. So rock, and scrolling down to the physics material on my capsule collider, let's just assign the rock physics material. Open this bad boy up, and then actually just with my rock selected, I'm going to make that, I don't know, maybe about 25 to 30% bigger. Let's see what that looks like. Yeah, not bad. Okay, and we can actually see that kind of bouncing through our game. I'm almost tempted to make it a little bit bigger, but you know what? I think that'll do for now. Calm down, Stephen, calm down. Yeah, that's plenty big. Now that we have that roughly where we want it, let's go ahead and add an impulse source to the rock directly. So Cinemachine impulse source as a component directly on this rock. Through testing, even with these most default bump settings, you know what, I think it's actually in a relatively good spot. But I think also even adding just a little bit of velocity on the X and the Z value would probably make sense. Nothing too drastic. Let's just change X to 0.2 and the Z value as well to 0.2. You know, if you really wanted to go the extra mile once we actually create our custom C# script, you could even go about randomizing some of these values each and every time the rock bounces, but I'm not sure we'll actually go that far. The next step to get this Cinemachine impulse source firing off is just to create a custom C# script and then fire that off through code. So let's navigate to our scripts folder. Let's see, which folder should we put it in? I don't really think any of them make sense, so I'll just actually put it in the root scripts folder for now. Let's create a mono behavior script, and let's just call this rock. Let's make sure we attach that to our rock game object, and then we can go ahead and open this up in VS Code. The first thing we need to do is just get a reference to that impulse source. So let's actually just grab that on awake. We can actually just look for the Cinemachine impulse source. We can just call that Cinemachine impulse source with a lowercase c, and we can actually just grab that directly on awake. So Cinemachine impulse source is equal to get component Cinemachine impulse source. And all we really need to do is actually just fire off this impulse source whenever we want to. Well, for now, let's just go ahead and create an on collision enter. Basically, every single time our rock collides with something, we can actually just fire off that impulse source. And yes, I know that you can also see what's coming, but we're probably going to want to add some conditions to this or it's going to get really out of hand really fast. For now, let's just go ahead and say Cinemachine impulse source, the reference we have above, dot generate impulse, and just call this built-in Unity Cinemachine method. This generate impulse method is really just the same thing as when we were tapping that invoke button before, except just through code. Nice, let's go try that out back in Unity. Let's actually click our obstacle spawner. At the moment, we have every obstacle spawning every 2 seconds. For all of our sanity and making sure we don't have too many rocks in our game, just constantly shaking the screen, let's actually just change that to 3 for now. Go ahead, open up our game view, and hopefully it's nothing too crazy. As soon as we spawn in a rock, moment of truth, yeah, there we go. Every single time the rock is actually hitting our bridge, even though it's making me a little bit dizzy at the moment because it's probably happening a little bit too often, we are generating that impulse. But I think it would actually be cool if we go add some additional conditions to our rock class to really sell the effect that the rock is a big, heavy object. I think we could actually do a relatively quick and easy distance check and then just actually kind of modify the generate impulse method using one of its built-in overloads to change how much it shakes based on how far away the rock is relative to the camera. The first overload that we can actually pass through generate impulse is actually just a float to kind of act as a modifier for how strong we want our rock to shake. We can actually just compare the distance from this transform.position relative to the camera, and then just modify our force float directly relative to how far away our rock is from our camera. And we can actually check that pretty easily. Every single time our rock collides with something, let's actually just define a new float called distance. And we can actually just set that equal to a built-in Unity method using a vector3. So vector3.distance, you can see here that it actually just returns a distance between point A and point B. Well, perfect. That's all we need. So let's go ahead and just use the transform.position of this rock. The second float we want to pass through is actually just the camera itself. So we can actually just use camera.main.transform.position. But this is going to return a pretty big number. The entire length of our bridge is, I think, basically like 120 units if we stack up all the chunks together. I don't remember how far away our obstacle spawner is, but point being is this is going to be some sort of number in between 0 to wherever our obstacle spawner is. So probably something like 50 to 60 units away. Well, the number we actually want to pass through this generate impulse method is really going to be a factor on how much we either want to increase or decrease the shake. In other words, if you were to actually pass through just one f, well, then it would be the exact same. So we want it to be something smaller than f if it's really far away, or we could actually just probably have it be exactly 1f if it lands directly on top of the camera. So let's have a think about how we could actually go about getting something like that. Let's create another float called shake intensity. And let's actually set that equal to 1 divided by the distance float that we actually just defined up top. That way we can make sure that this number is always going to be less than 1 unless it lands really, really close to our player. So really all we want to do is kind of clamp this to make sure that it's never actually greater than 1. Even if the rock lands directly on our camera, it's never going to actually be a greater than 1 number. You definitely could use mathf.clamp. However, in this case, we really only care about the minimum amount. So in our case, we can set shake intensity equal to mathf.min and then just pass through two different floats. We can just say shake intensity or 1, meaning that if shake intensity ever returns more than 1 because it landed extremely close to our player, it will still just return the minimum value between these two floats. In other words, it will never return more than 1. So in our case, now that we actually have this shake intensity pretty close to where we want it, we can actually just pass that through into our generate impulse method. Great, with that created, let's go try that out back in Unity. If we keep a close eye on actually when the rock is exactly hitting the bridge, you can see that it actually is working. The closer that it's actually getting to the player, or more specifically the camera, it is working, but it's probably just not quite strong enough. Well, there's a few different ways that we could actually go about fixing that. We could actually just hop back directly into our rock class and add a custom modifier. I think that would actually work just fine. We could also go to the Cinemachine camera, scroll down to our impulse listener, and we could even change this gain property. If you were to say change this to something like 10, it's going to take all of the sources that it ever gets and actually just amplify them by a gain of 10, so a factor of 10. So again, that would work just fine as well in our case. We don't actually have a lot of different sources in our game at the moment, but I kind of tend to like keeping the gain at 1, so let's go add a modifier back in our rock class. At the top, let's create a serialized field. We'll just create a float and we'll call it shake modifier, and I think setting it to something like 10f is pretty reasonable. I think the most appropriate place to add this to is our shake intensity where we first define it. Let's take 1f divided by distance and then just times that value by shake modifier. So even though this first defined field is actually going to sometimes still once again be 10 times greater, we'll still never return more than 1. Let's go see what that looks like back in Unity. All right, let's see what that feels like. Yeah, when the rocks are actually slamming down pretty far away, our camera is not shaking too drastic. As the rock comes closer, or even if it hits our player, we're actually getting a much higher shake effect. But I think we can actually take this one step further and really add some destruction to our scene with a custom mesh particle effect. When you're ready to implement that feature, we'll tackle that in the next lecture. I'll see you there.